Okay, we're going to learn about angle relationships. Hi, you're an acute angle. Thanks for the compliment. Let's get ready. You're going to need something to write with in your notes. Be sure to try every problem and be sure to take notes on the last slide. Today we're going to determine the relationship between angle pairs. We'll work through 3 problems together. We're going to write the equation that's represented by the relationship, solve and answer the full question, and state why this is true. So here we have this picture and we're asked what kind of angle pair is it? In order to answer the question, find the measure of angle LOM. So we want to figure out what the relationship is between these purple and green angles. And I do notice I have this right angle marking, so I know that these are going to add up to 90. So our vocabulary word here is complementary. And we're going to have that help us write our equation. So when we write the equation, we want to use our letters first. So I'm going to do angle LOM, the measure of angle LOM, plus the measure of angle MON equals 90 degrees. And then we're going to substitute in the expressions. So LOM is 2x plus 46. I am going to put it in parentheses just to show that that represents that angle. It does not mean distributive. The measure of MON is 3x minus 6 equals 90. And I'd like you to go ahead and pause it here, try to solve for x, and continue on to answer the question. Find the measure of angle LOM. So when you combine like terms, I have 2x and 3x to give me 5x. I have 46 minus 6 to give me 40 equals 90. Then I subtract the 40 from both sides to get 50, divide by 5, and I get x to be 10. But remember, that's not the question. The question wants to know, find the measure of angle LOM. So it's usually another step. Don't just stop when you have x. So I want to look at LOM. So I'm going to be plugging the 10 in here. So 2 times 10 plus 46 is 20 plus 46 for 66. Remember that when you're solving for x, that does not mean degrees. That is just the number that your variable represents. When you solve for the angle, that is 66 degrees. So I included those units there. Now my question becomes why? Why can we do that? The answer is the definition of complementary. Let's look at another example. And here we have this picture. We're asked to find angle DBC. So that's the angle we want. So we want to figure out what the relationship is between these two angles. They both are on a straight line. And we're going to try to figure out the relationship so we can write our equation. Because they're on a straight line, we can say that they add to 180. That full line equals 180. So I'm going to use my letters again to write my equation. The measure of angle ABC plus the measure of angle DBC equals 180. Then we can substitute in our expressions. So ABC is x plus 1, DBC is 3x plus 19. Pause the video here and try to solve for x and continue on to find the measure of angle DBC. When I combine like terms, I'm going to get 4x plus 20 equals 180. Subtract 20 from both sides and you get 160. Divide by 4 and you're going to get 40. So I know that x is 40. I'm not done with the problem yet. We need to plug it back in to get DBC. And make sure you're going into the right angle, the correct angle. We want to go there. So we end up with 3 times 40 plus 19, which is 139 degrees. Again, the question is why? Why am I allowed to even do this in the first place? And this one actually has 2 possible answers. Because it's together on a straight line and we know they're going to equal 180, we could say definition of supplementary, or we could say linear pair postulate. Remember, a linear pair is 2 angles on the same line, so linear pair postulate we can abbreviate that LPP, says that the linear pair angles are supplementary. And here's our third and final example. What kind of angle pair do we have here? We're trying to find the measure of ABE, this piece over here. This is our X picture. We have two intersecting lines. They intersect at point M. We want to figure out the relationship so we can write an equation. Because these are across the vertex from each other, these are going to be vertical angles. And we should remember that vertical angles are going to be congruent, so I can put the congruent marks on there. Let's write it out as an expression. So we have the measure of angle ABE and the measure of angle DBC, and they're equal to each other. They're not adding to 90, they're not adding to 180, they are just equal to each other. So go ahead and fill those expressions in. And we end up with 7x minus 24 equals 4x. Pause the video, solve for x, and solve for your angle. When I subtract 4x from both sides, I'm going to get 3x minus 24 equals 0. I want to add the 24 over, and I get x to be 8. That's my variable, not my degrees. When I plug it back in, if I plug it into here, I'm going to get 32, which means if I plug it in here, I should also get 32. So let's check. We have 7 times 8 minus 24, which is 56 minus 24, which is in fact 32. And it checks out. So my variable was 8, measure of angle ABE was 32, and my question is why? Why can we say that? Because they're vertical angles, and it's the theorem, the vertical angle theorem, that says vertical angles are always congruent. We can abbreviate that with VAT. So some notes for your notebook. Angle pairs. When you're determining the relationship, do they add to 90 degrees? That would be complementary. Do they add to 180 degrees? That would be supplementary or linear pair. Are they equal? That would happen when you have vertical angles. Write down those relationships as an equation, solve for x, and finally answer the question. Good job.